Hello students, let's take up a question from electricity chapter and solve it. The question is resistance of a wire of length 1 meter is 35 ohm at 20 degrees Celsius if the diameter of the wire is 0.2 millimeter. Determine the resistivity of the material of the wire at that temperature. How will the resistivity of the wire change if the length and diameter of the wire both are doubled? Justify your answer given that pi is 22 by 7. Alright, so let's first write down what all are given. So the length of the wire is given as 1 meter. Then the resistance is given as 35 ohm. Then the temperature is given here is 20 degree Celsius. Now the diameter of the wire is 0.2 millimeter, which is 0.2 into 10 to the power minus 3 meter, which is 2 into 10 to the power minus 4 meter. So this is your diameter. Now we have to determine the resistivity of the material of the wire. Now we know the formula for the resistance is given by R is equal to rho L by A. So resistivity will be R into A by L. So now we have the resistance which is given as 35 ohm, but we don't know the area of cross section. So let's find out. So the formula for area is given by area is pi R square, which is pi d by 2. Radius is half of diameter, its square, which is pi. D is 2 into 10 to the power minus 4 meter. So it is 2 into 10 to the power minus 4 by 2, its whole square. So 2 cancels over here. So it is pi into 10 to the power minus 4 into 2 is 8 meter square. So the area of cross section is pi into 10 to the power minus 8 meter square. So we'll substitute the value of area in this place. So it is 22 by 7. We'll put the value of pi is 22 by 7 into 10 to the power minus 8 divided by the length is given as 1 meter. So it is 1 into 7 in the denominator. So now we can cancel 35 with 7, which is 5. That comes to be 110 into 10 to the power minus 8 ohm meter, which comes to be 11 into 10 to the power minus 7 ohm meter. So either you can write the value of resistivity as this much, which will give you the value of resistivity as 1.1 into 10 to the power minus 6 ohm meter. How did we get this? 11 into 10 to the power minus 7. Here multiplying and dividing 10 to the power 1 in the numerator and the denominator, we get it as 1.1 into this 10 to the power minus 7 and that's 10 to the power plus 1 gives us a value of minus 6. So in this way the resistivity value comes to be 1.1 into 10 to the power minus 6 ohm meter. So this is the value of the resistivity of the material of the wire at 20 degrees Celsius. Now how will the resistivity of the wire change if the length and diameter of the wire both are doubled? The answer to this will be there will be no change in the resistivity of the wire, as resistivity depends only on the nature of material of the wire, and here the material is not changed. So since the material is remaining the same and resistivity is the intrinsic property of that material of the wire, so there will be no change in the resistivity of the wire. So this is the answer to this question. I hope you have understood it. Thanks for watching. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.